Dear Study Prep, today we will introduce a new lesson for the new term with geometry, lesson 1, unit 4, basic definitions and concepts of the circle. With Mrs. دعاء الجيزاوى with you today. The first lesson is about the circle. This term we will explain the geometry lessons together. All about the circle. First, we have to know what is the circle. The circle is a set of points which are at constant distance from a fixed point on the same plane. First, I have different points like this. These points together will make a circle if these points at certain distance from a fixed point. This fixed point here is called the center, and the fixed distances are called the radii of the circle. All radii of the circles are equal in length. Now, this point, we said before, this is the center, this is the radius, and the length of the line from joining 2 points on the circle passing through the center, it's a diameter, and any circle has an infinite numbers of diameters, and we know that the diameter is equal radius times 2, or the diameter is double the radius, and the line segment joining 2 points and not passing through the center, it's called chord. Now we have the center of the circle, which is the point, the fixed point, which is any point on the circle and at fixed distance from this point, the fixed distance, which is the radius length from the center to the circle, any line from the circle to the circle passing through the center is diameter, and any line joining 2 points on the circle not passing through the center is called chord. يبقى the chord, it is a line segment whose end points are any 2 points on the circle and not passing through the center. You have to remember that the circumference of the circle is 2 pi r, and the area of the circle is pi r power 2. You have studied all these concepts before. For example, the circle of radius length 7 centimeters. Its circumference, to find its circumference in the area, we use the radius and pi, which is 22 over 7. So to calculate the circumference here, we will make 2 times pi times r, or 2 times 22 over 7 times the radius length, which is 7, equal 44. And to calculate the area, which is pi r power 2, equal 22 over 7 times 7 power 2 equal 154. Another example. In each of the following figures, find the value used sample using the measure m in the center of the circle. We said in the last slide that all radii of the circle have equal lengths. So this information you have to memorize well, because we have a question like this. It depends on this information. If this triangle is MB is the radius, MA is the radius, and the AB is a chord, this triangle formed from 2 radii and a chord, it's an isosceles triangle. It's an information he won't tell you about. That's what, since once you find that MA and MB are 2 radii, so they are definitely equal in length. So this triangle is an isosceles triangle, so to find the value of x here equal to 30 degrees, because measure of angle A equal measure of angle B. You have studied before that the isosceles triangle, two equal sides give you two equal angles. Another example. Here, I want to find the value of x and y. And I have CM is a radius, DM is a radius, BM is a radius, and I have DM equal to MDA. First, when DM equal to DA, so the triangle DMA is an isosceles triangle. So the angle A equal to angle DMA equals 25 degrees. So now I can find the value of x. X here is an exterior angle to this triangle. If you extend the line AD, it will give you an exterior angle here, x. So I can find x using the rule of the exterior angle, which is the sum of two non-adjacent angles equal 50 degrees. Now, we will go to the other triangle, which is CDM. Now, you know that CD is a chord, CM is a radius, and DM is a radius. So this triangle is an isosceles triangle. CM equal DM equal R. So to find measure of angle Y in the isosceles triangle, first we know that measure of angle C equals CDM equal 50. So Y here is 180 minus 50 times 2 equals 80 degrees. We have two important corollaries, three important corollaries. Number one, the straight line passing through the center of the circle and the midpoint of any chord of it, it's perpendicular to this chord. For example, if I have a chord like this one, AB, and I draw a line from the center to the midpoint of this chord, what will happen? Will happen that I will find that this line is perpendicular to this chord. So if you draw a line from the center to the midpoint of the opposite chord, this line is perpendicular to this chord. Corollary number 2. So if CA equals CB, so MC is perpendicular to AB. Corollary number 2. The straight line passing through the center of the circle and perpendicular to any chord of it bisects this chord. It's the opposite or the converse of corollary number 1, which is if I have a line from the circle perpendicular to a certain chord, what this line do? It divides or bisects the chord. So if I draw a line from the center to a chord perpendicular to this chord, so this line bisects the chord. Corollary number 3, so again, MC perpendicular to AB, but therefore CA equal CB, or C is the midpoint of AB. Corollary number 3, the perpendicular bisector of any chord passes through the center. It's included 1 and 2. If there is line perpendicular to the chord and bisects the chord, so it has to be passing through the center. So this line, it must be passing through the center. For example, in the opposite figure, I have here a circle M. AB is a chord. C is the midpoint of this chord. Measure of angle BMC is 63 degrees. And he wants to find the measure of the angle MAB. Now, I have corollary tells that the line from the center to the midpoint of the opposite chord perpendicular to this chord. Excellent. So AB is a chord in the circle M. C is the midpoint of this chord. Therefore, MC is perpendicular to AB. Okay, so I have right angle here, MCB. Now, this angle is right. To find BMC, BMC is 63, so I can find MBC using the right angle triangle, the small one, MBC. It's 180 minus 90 plus 63 equal 27 degrees. This angle is 27. Again, he won't tell you that MA and MB are two radii, then they are equal in length. This information, you will know it yourself. Concentrate, if I have two chords, it makes an isosceles triangle here. So if this is an isosceles triangle, therefore measure of angle A equal measure of angle B equal 27 degrees. And this is our require. Another example, in the opposite figure, I have here AB and AC, two chords. E and D are midpoints of AC and AB. Find a measure of angle DME. Again, if D is a midpoint of AB, midpoint of a chord, line from the center, so MD is perpendicular to AB. So this angle is 90 degrees. Again, E is the midpoint of the other chord. So ME from the center to the midpoint is perpendicular to the chord. And this angle made by this line AEM equal to 90 degrees. Now, look at the figure. You will find that AEMD is a quadrilateral. I have measure of angle D, measure of angle E, and measure of angle A, and the missing one here, which is M, what it's the required in the example. Since with any quadrilateral equal 360, therefore this angle is 360 minus these angles equal 124. And this is our lesson today. Thank you very much.